This is the case of a patient with primitive dilated cardiomyopathy implanted with an ICD. In this tracing, we will highlight the interests of programming anti-tachycardia pacing in the VT zone. A priority of defibrillator programming is to minimize as much as possible the delivery of shocks without compromising the patient's safety. So one must adopt the least aggressive and least painful treatment modality to terminate an arrhythmia. So anti-tachycardia pacing must be favored as first-line treatment of organized ventricular tachycardia because compared with an electrical shock, it is painless, and by limiting the energy consumptions, it lengthens the life of the battery. And more importantly, we know also that the delivery of electrical shock is associated with an alteration of the prognosis of the patient. We can see on the plot here an acceleration, a ventricular tachycardia detected, and then a burst is delivered with a return to sinus rhythm. We can see here an episode of stable VT, the initial detection of the VT, then the burst is delivered with a return to sinus rhythm. A burst stimulation sequence consists of a train of pacing pulses with the same cycle length all along the pacing sequence. The burst is the most commonly used type of sequence in clinical practice. The principle behind anti-tachycardia pacing is to capture the arrhythmia and interrupt an organized VT. So the ventricle must consequently be paced at a faster rate than that of the tachycardia. The ATP pacing interval here, 270 milliseconds, is based on the ventricular tachycardia cycle length, which is calculated as the average of the last 4 ventricular intervals preceding the VT detection. So the pacing interval for the first burst sequence is a calculated percentage of the cycle length of the tachycardia. This is the same patient with another episode of VT requiring 4 sequences of anti-tachycardia pacing. In this patient in the VT zone, various sequences of therapies were programmed, beginning by a series of bursts with fixed rate pacing, followed by a series of ramps with programmable decrement of the pacing interval from one cycle to the next, followed by a series of electrical shocks. In this episode, we can see that the 3 first bursts were inefficient, so a ramp was delivered with a return to sinus rhythm. You can see here the ramp on the EGM. A ramp stimulation sequence consists of a train of pacing pulses with an automatically decrementing inter-stimuli intervals. For example, here you see that the first pulse is delivered with a coupling of 310 milliseconds, whereas the last one is much more aggressive with a coupling of 240 milliseconds.